that we're going to be using to solve the system using matrix operations is called Gauss elimination. Okay, so for example, here it says use a matrix to solve the system. So before I use this example, let me go ahead and we can start with the example we had before. Let me just get a piece of paper. So let me work out the previous one first. And this is the one that I'm talking about. So x plus y equals 4, x minus y equals 2. So the instructions are solve the system using matrices. So first we need to write this system into a augmented matrix. Okay, so always remember your goal is to make this matrix look like this matrix where you have 1 in the diagonals and then zeros everywhere else. Okay, so first, our first goal is to make this a 1. And so if you notice here, we already have a 1. So we don't have to do anything. Then you're going to use this one to make everything below it a 0. You could make this a 1 first, but it might make you work in circles. So the best thing would be to use this diagonal to make everything below it a 0, and then you work with the second diagonal. Okay, so in order to make this a 0, I need to make sure that when I add the 2 rows, it's going to be a 0. So what we can do is we can multiply row 1 by a -1 added to row 2, and then place our results in row 2. Here, what we're changing is row 2. So I'm not going to change row 1, so I'm just going to write it down. And so now I can multiply this row 1 by -1. -1 times 1 is -1, plus 1 gives me a 0. -1 times 1 is -1, plus a -1 gives me a -2. And -1 times 4 is -4, plus 2 is -2. Okay, so now your next goal is to make this diagonal 1. So in order to make this diagonal 1, I would have to multiply row 2. I'm going to multiply it by a -1/2 times row 2 and place my answer back in row 2. So here I'm not changing row 1, so I'm going to write row 1. And now for row 2, I'm going to multiply by -1/2 times 0 is 0. -1/2 times -2 is +1. And -1/2 times -2 is +1. Okay, so now I have my 1. So now we're going to use this one to make everything above it and below it 0. In this case, we only have stuff above it, so I need to make this a 0. So I'm going to go ahead and just come down here so we can have more space. So my matrix was 1, 1, 4, 0, 1, 1. So I'm going to multiply -1 times row 2. I'm going to add it to row 1, and I'm trying to change row 1, so I'm going to put my solution back into row 1. I'm not going to change row 2, so I just place it down or write it down. And so now I'm going to multiply -1 times 0 is 0, plus 1 is 1. -1 times 1 is -1, plus 1 is 0. And -1 times 1 is -1, plus 4 is 3. So now, if you notice, we have reached our goal where we just have 1s in the diagonal and 0s everywhere else. And so from here, since I'm working with x and y, then the first number here represents x. So x is equal to 3 and y is equal to 1. And so this